The second part of this is to talk about what probability is. And probability is just likelihood. So if you want a synonym for probability, it just means likelihood. How likely is something to happen? That's all. And so we can define this in terms of percentages. So if I say it is not at all likely to rain 100% sun, such as it is actually today and tomorrow, P equals 0, probability equals 0. It is, and that means it's impossible. Okay, P equals 0 means it's impossible, or 0%. On the other side, you've got P equals 1, or really what we mean as 100%. And that means we're 100% certain. So this is certain, okay? And then in between, we have P equals 0.5. That's the midpoint. That's where it's equally likely or unlikely. In other words, it's a 50-50, right? So that's equally likely to happen or not to happen. So equally likely to happen or not to happen. Then we have P equals 0.25, or 25% probability, right? And that's just, say if I said it's a 25% probability of rain, you'd say, oh, well, then I can go and expect to enjoy my picnic. That means it's really not going to rain because rain is unlikely. On the other hand, if I said P equals 0.75, or if I said, I should put 0%, if I said there's a 70% probability of rain, and you're thinking, okay, it's kind of likely, right? I'll bring an umbrella, right? I'm going to expect that there's rain. So that is the definition of probability. Now, there's a couple ways of looking at probability. I'll turn this over because I get marks on the paper. There are two probabilities, believe it or not. There's theoretical, and theoretical was that first problem we just did, which is like heads. You have a coin, right? And you have heads or tails, right? The theoretical probability means what will happen if everything works itself perfectly. So theoretical probability is the number of favorable outcomes over the total number of outcomes. And this is in theory, not in practice, okay? And the probability of an event is written as a probability of the event A. Number of favorable outcomes over the number of total number of outcomes. Now this is, for example, this, if you're talking about the theoretical probability of getting heads or tails, we know it's 50-50, 0.5, right? Because total outcomes is all the number of coin. So you toss the coin 10 times. The theoretical outcome is that it'll be 5 heads for 10 tosses, right? So it's a 0.5. The experimental probability, which we'll talk about in a minute, is what actually happens when you toss it. Okay, so the experimental probability, and I'm just going to put it underneath even though it's not combined in the book. The experimental probability is expressed as the number of successes over the number of trials. Okay, and this is the experimental probability. Now this is what should happen, right? Heads or tails, you should get 50%. Experimental is what actually does happen when I take a coin. And what you'll find is when you do it 10 times, you might really only get heads 3 times out of 10. But the closer you get to a very high number of trials, the closer you get, say, to 100 trials, the closer the number of successes will approach the theoretical probability. So the more you do, the closer you'll see that it'll get to that 50% theoretical probability. And this is really important. That's one of the reasons that when you design an experiment, you design it with a lot of different trials, because that's how you get the most accurate information. Okay, so let me do the 2 examples and then we'll end.